Hello everyone, I'm Janvi. So today we'll look forward with the topic generics, classes, hierarchies. So the topics to be covered are introduction to generics, key concepts and definitions, generic classes in Java, derived generic classes, using generic classes in Java, wildcards in Java, best practices for using generics, and then we would conclude. Introduction to generics. Generics in Java are powerful features that allow classes, interfaces, and methods to be parameterized by different data types. This means that they can work with different types of data in type-safe manner, ensuring compile time checking rather than runtime errors. The importance of generics lies in the ability to enhance the code flexibility and reusability by enabling developers to write generic algorithms and data structures that can be operated in different data types. So the main feature of generics is that they can be used for different data types. The same code could be used for different data types where we need to initialize the type of data that is being used in the main class. Key concepts and definitions. So let's look further into how generics work and how it needs to be implemented in our program. Type parameter in Java generics, a type parameter is a placeholder for specific type that can be specified when invoking a generic class or method. Commonly, it has been represented by a single uppercase letters. They enable the creation of generic classes and methods. They are reusable with different data types. Type safety. Generics ensure type safety by providing compile time type checking. This prevents operation on incompatible types, reducing the likelihood of runtime errors such as class cast exception. Parameterized classes. A parameterized class in Java is a class that accepts one or more type parameters. It allows the class to be initiated with different types, making the class more versatile and reusable. So a main class or method will be initialized with type parameters, and the type which is being used, which needs to be run in the program, is being initialized in the main body. Generic class in Java. A generic class in Java is defined using an angle brackets to specify one or more type parameters. This allows the class to operate on objects of different types while providing type safety. The type parameter can be used throughout the class definition to define fields, methods, and constructors that work with the specified type. So here in this example code, container T is a generic class with a type parameter T. Is a generic class with a type parameter T. It can hold an object of any type T, and a constructor and a method getItem are also been using the item T, and type safety ensuring that only objects of type T are stored and retrieved. So here container is a generic class, and the T, capital T, which is been given in angular brackets, is a type parameter, and its data type is being initialized in the main body, stating whether it's an integer or a string data type. Accordingly, all the operations will be followed. Derived class in Java. In Java, a derived class can be an extent of a generic class, inheriting its generic type parameters and functionality. This allows the derived class to specialize and extend the behavior of generic class while maintaining type safety provided by generics. So here in the example code, box T extends the container T. Here the container T is a generic class and box T is an derived class which inherits the features of the generic class. It inherits the item field and get item method from container T and adds a display item method to print the item stored in the box. The type parameter T is preserved, allowing box instances to work with any data type T. Using generic classes in Java. Generic classes in Java are instantiated with specific data type, allowing for flexible type-safe operations. Instances of generic classes can be created with different types enabling code reuse without compromising type safety. So here in the example code, string box and int box are the instances of box class with specific type parameters, string and integer respectively. Each instance maintains type safety while allowing different types of data to be stored and retrieved. Wildcard in generics. Wildcards are being denoted by question mark. In Java, generics provide flexibility when working with generic types. They allow methods and class to accept generic types in more general way without specifying a concrete type parameter. Wildcards include unbounded, upper bounded, and lower bounded forms. So let's discuss some best practices for using generics. Best practice for using generics in Java: ensure clean and efficient code that leverages the full potential of generic class hierarchies. Use descriptive name of type parameters to improve code readability and maintainability. Avoid using raw types list instead of list objects as they bypass generic type checking. Prefer list angular bracket e over arrays e for type safety and flexibility in collection. Use upper bounded wildcards and when methods can accept any type that is a subtype of T. So I would conclude that generic class hierarchies in Java provide a powerful mechanism for writing flexible, reusable, and type-safe code. By using type parameters, developers can create classes and methods that operate seamlessly with different data types, ensuring compile time or type checking and reduces runtime errors. Thank you. I hope that the information was useful to you.